This question is question 12. There are quite a number of parts to it. It starts by saying, find the derivative of this semicircle. Now I can tell it's a semicircle because if I rearrange it just a little bit, I get the form that I'm familiar with. X squared plus y squared is 169. This is a circle. In fact, I only want the positive component of centre 0, 0 and radius 13. So it asks me to find the derivative of this. So the first thing I'm going to do is rewrite this just using index notation. Then I can use the chain rule. Times this by the derivative of what's in this side, which is minus 2x. A half of minus 2x will just be minus x on the top. And the 169 minus x squared is on the bottom, and it's a square root, so that can go there. This is my derivative. That was the first part of the question. The next thing it asks me to do is sketch the semicircle. So I've already done a little bit of that work over here. Very rough axes. So it's just a sketch. Centre 0, 0. Radius square root of 169, which is 13. And I just want the top half. A bit wonky, but it will do for now. The next part of the question is a continuation of it. So it's going to use a little bit of information. It says show that the tangent at this P, which they give us to be 12, 5, is equal to 12x plus 5y equals 169. So they say show that the tangent is equal to this. So to find the equation of a tangent, we need two things. A point, which we have, and the gradient at that point, which we don't have yet, but is easy to find. We need to use the gradient function, which is, of course, our derivative here. So we're just going to write that on this page. Minus x over 169 minus x squared. And what I want to do is evaluate that at this point. So what I want to do is evaluate the gradient at the point 12. So I substitute 12 into here, I get minus 12 divided by the square root of 169 minus 12 squared, which is 144. Minus 12 divided by 160, the square root of 169 minus 144. So 144 to 150 is 6, and another 19 is 25. This gives me minus 12 fifths. Now this is my gradient, and this is my point. So now we're going to use our point gradient formula. And what we're looking for, hopefully, is this equation. So we've got y minus 5, 12 minus 12 fifths, lots of. Sorry. X minus 12. And now so do some expansion, tidy this up a little bit. Minus 12x on 5. Minus times a minus will become a plus. 144 fifths. It's a bit messy at the moment. Let's go with it for now. I'm going to multiply this and this by 5. So 5y minus 25 minus 12x plus 44. That's a little nicer. I need to try and see if I can get it to look like this. It's looking promising. Move the 12x now. Left side. I get 12x plus 5y. And I might in the same step move the 25 as well. So now I've shown exactly what they asked us to show, that the tangent at this point was equal to that. 12c. Again, a continuation of the same question. What it asks for now is to verify that the tangent at P remember that the point P was 12,5, is perpendicular to the radius at P. Now, that's a little bit complicated to try and understand. If it's perpendicular to the radius at P, that means that the line from 0 to P is a straight line and is also the radius. If it's a straight line passing through the curve, and if it is at 90 degrees at this point, then what we're actually thinking is we're assuming that line OP is the normal. If we can prove this is the case, then we will have proven that the point 12,5 is perpendicular to the radius at P. So let's see how we can find out if OP is the normal. So what we have is a point P, 12,5. The gradient of the normal will be the negative reciprocal of the tangent, and the tangent was minus 12/5, so the gradient of the normal should be 5/12. I'm just going to find the equation of the normal. So here's my equation of the normal. What I want to do now is verify that the origin is on this line, and then I've shown that the line from the origin to 2.25 is in fact the normal, and therefore the tangent is perpendicular to that. So when x is 0, y is 0, therefore passes through the origin. This is a meaty question. The next one. This is the last component. So, the last little bit. Sorry, just lining up the page here. 12D. It's in a couple parts. It says, find the x-intercept and the y-intercept of the tangent. Now we've already got the equation. The equation of the tangent is 12x plus 5y equals 169. X-intercept happens y equals 0. So evaluating this when y equals 0, I get 12x equals 169. The y-intercept happens when x equals 0. So make this into 0. I get 5y equals 169. So y is 169 divided by 5. Then it asks me to find the area of the triangle enclosed by the tangent and the two axes. So what we have now is our two axes, a point, 169 twelfths and 0, that's that here, and a point 0, 169 fifths, which is here. So it's saying find the area of the triangle enclosed by the tangent and the two axes. Find this area. So the area is half of the base times the height. My base, 169 twelfths. My height, 169 fifths. The last thing is to find the perimeter. So now the perimeter. From 0 to the 169 twelfths and the 169 fifths, this length, this length, this length. This one is the square root of 169 twelfths squared plus 169 fifths squared. For this, I'm just going to grab the calculator out. It's getting a little bit beyond my effective mental calculation. And then the total perimeter will be 169 twelfths plus 169 fifths plus whatever I get here. So let's see what happens. One 169 twelfths squared plus the 169 fifths squared and then what I want is the square root of that. And it actually works out to be approximately 36.2. I'm going to add that to my 169 twelfths and my 169 fifths. And my perimeter is 84 and a half.